Okay, let's continue on to find the volume of a pyramid or a cone. The volume for pyramid or cone is similar to the volume of a prism or a cylinder, except that it is 1/3 of the size. So the volume of a pyramid or cone is going to equal 1/3 times the area of the base times the height. Or if you want to think of it, area of the base times the height, and then divided by 3. And like I previewed earlier, that formula is also on the MCA formula sheet and the formulas that you'll be given for the ACT, all that good stuff. So let's try a few examples. The volume of this pyramid is going to be 1/3 the area of the base times the height. Well, this shape is a triangle. So that is, I'm actually going to keep this color coded. Area of a triangle is 1/2 base times height. Well, the base here of this triangle is either 6 or 8, and the height is the opposite one. So that is 1/2 6 times 8, and then times the height of this pyramid. Well, the height that we're going to work with is the true height. We are not going to work with the slant height when it's volume. So the true height is 12, and then we punch all this into our calculator. 1/3 times 1/2 times 6 times 8 times 12 is 96. We don't have any units on this, so I'm just going to say that it's units, and because this is volume, it is cubed, so cubic units there. So let's find the volume of this cone. The volume of a cone is 1/3 area of the base times the true height. So volume equals 1/3. Well, the area of the base is this area of a circle. So that is pi times radius squared. And we don't necessarily have the true height yet. So we are going to have to find that one. So volume equals 1/3 pi times our radius is 5 squared times our height. Well, we don't have that, but we know information about this triangle that I'm just going to draw out here. This is a right triangle. This distance is 5. H is what we're looking for. And we know that this angle here is 20 degrees. So if we know an angle and a side length, and we're trying to find another side length, that means we have to use one of our trig ratios, SOHCAHTOA. Sine, cosine, or tangent. And related to this angle here, we have the opposite side, and we're looking for the adjacent side. So opposite and adjacent is tangent. So tangent of 20 degrees equals 5 over h. Got to get rid of that denominator. So we have h times tangent of 20 equals 5. Divide both sides by that tangent of 20. So then our true height is going to be 5 divided by tangent of 20, about 13.7. So that is our height that we are plugging in over here. times 1/3 times pi times 5 squared. So our volume of that cone is going to be 359.6 meters cubed. All right, let's find the volume of this rectangular pyramid. So it's not even a square pyramid, it's rectangular, but the process is the exact same. 1/3 area of the base times the true height. So volume equals 1/3. Well, the area of the base is just going to be 10 times 16. I'll make that look a little more like a 16. And then to find this true height, we need to do Pythagorean theorem. So this triangle we have right here, we know that the hypotenuse is 16, and we can figure out what this base length is because we don't have an oblique pyramid. That would be way too difficult. This true height, this point that it ends here that's perpendicular, is halfway to the side. So then this is going to be 8 meters. And then we're just going to use Pythagorean theorem. 16 squared equals, 8 squared plus h squared. And then again, I can do this single variable algebra without showing all the steps because this is something that we've been doing for almost the entire school year. So that is approximately 13.9 centimeters equals that true height. So that just goes right here. And we throw all that into our calculator and see what we get. 1/3 times 10 times 16 times that true height. And that is 739. It actually rounds to 739 cubic centimeters. And lastly, we can find the volume of spheres and other composite figures. So we're going to jump right into that. The volume of a sphere, we're not going to explore how to find that one either. That is just 4/3 times pi r cubed. 4/3 times pi r cubed. And again, that formula is also in your given formula sheet. So let's do an example. The diameter of a baseball is 7.5 centimeters. All right. 7.5. And the diameter of a softball is 9.6. How much more volume does a softball have than a baseball? Well, that means we need to find the volume of each of those. The equation for volume is 4/3 pi r cubed. So that means we need to find the radius of each of these. Well, I gave you the diameters. So then the radius of the baseball is 3.75 centimeters. Radius of the softball is 4.8 centimeters. So we just calculate these volumes. Volume equals 4/3 pi times 3.75 to the third power, which equals 220.9 cubic centimeters. And then the volume of the softball is 4/3 pi times 4.8 cubed. So that volume is 4/3 pi r cubed. So that is 463.2 cubic centimeters. So then to find how much more volume the softball has, we just subtract them. 463.2 minus 220.9 equals 242.3 cubic centimeters more. So it's twice as much volume to a softball than a baseball. Even though it doesn't look like it's twice as big, it has twice as much volume. That's pretty cool. All right, now we're going to go in reverse. Here it says a sphere has a volume of 288 pi cubic centimeters. What is the radius of the sphere? Volume is 4/3 pi r cubed. So I'm telling you that that is 288 pi. So if we want to solve for the radius, we have to get that by itself. Well, we can divide both by pi. That cancels out. So then we have 4/3 radius cubed equals 288. Well, to undo that 4/3, we just multiply by the reciprocal, multiply by 3/4. And those cancel out, those cancel out. So we have r cubed equals 288 times 3/4 is 216. And then to get r by itself, we have to take the cubed root of both sides. So then r equals, well, the cubed root of 216 equals 6. And what were the units on that? Was that centimeters also? Yep. So the radius is 6 centimeters. And then we have a few composite figures to just end this lesson with. So this first one, it looks like we have a piece that is a cone. We have a piece that is a cylinder. And then we have a piece that is a semicircle or semi-sphere. It's half a sphere. Okay, so I'm going to do the cone first. Volume of the cone. That is 1/3 area of the base times the height of the cone. So we're going to scroll down a little bit. It doesn't give the radius here. Oops. It doesn't give us the radius. But fear not, we can figure it out. And that is because we're going to look at the sphere down here. It says that this distance, so from here to that, is 3.5 centimeters. Well, that is the radius of this sphere. So the distance, so this is 3.5. That also means that this distance is 3.5. So our radius is, in fact, 3.5 centimeters. Whew, that was going to be scary. So area of the base is pi r squared, pi times 3.5 squared, times the height of this cone. Well, we don't have that either right now, but this is the height. We know that this full distance is 12.8. We know part of it is 6.5 and part of it is 3.5. So we just subtract those out. 12.8 minus 6.5 minus 3.5 means that this part up here has to be 2.8 centimeters. So that height there is 2.8 centimeters. We plug all that into our calculator. 1/3 times pi times 3.5 squared times 2.8. And that is 35.9 cubic centimeters. Now let's move on to the cylinder. So that is just the area of the base times the height. So it's the same circle. That's the base. So it's going to be pi times 3.5 squared times the height of the cylinder now, which is 6.5. Can get rid of that. So then that volume, pi times 3.5 squared times 6.5, is 250.1 cubic centimeters. And then lastly, we have the volume of the half sphere. So let's just find the whole volume of the sphere and then we'll cut it in half. So volume of a sphere is 4/3 pi r cubed. So 4/3, nope, I don't need the parentheses yet. Pi times our radius is 3.5 cubed. And that volume is going to be 179.6, but we need to cut it in half because we only have half of that sphere. So we actually want, let's see, that is 89.8 cubic centimeters. And then we just add these three volumes together. We don't have to subtract anything out because it's not a surface area, it's a volume. So the total volume is going to be 35.9 plus 250.1 plus 80, oops, the color didn't change, plus 89.8. So that is 35.9 plus 250.1 plus 89.8. So that is approximately 375.8 cubic centimeters. And that's how you find the area of a composite figure. I'm sorry, the volume of a composite figure.